Hello and welcome to today's Saratech Customer Enablement Series. My name is Sarah Utsugi and I'm the Marketing Coordinator at Saratech and I will be your host today. Presenting today, we have two special guest presenters from HCL, Senior Application Specialist Marc Bissell and Product Specialist Ben Gowers. Today, they'll be talking to you about automated smart manufacturing and solid edge. All right. Hi, Marc and Ben. Thank you so much for joining us. How are you both doing today?
Hi, Sarah. We're doing well, thank you.
Awesome. Can you tell us a little bit about yourselves and what you do at HCL?
Sure. My name's Marc Bissell, and I'm the Senior Application Specialist for the CamWorks product and CamWorks for Solid Edge, and that's what we're going to be talking about today. And with me is Ben Gowers. Ben, would you like to introduce yourself?
Sure thing. Thank you. My name is Ben Gowers. I've been in CAD and CAM since I started learning CAD in 1990, and shortly after there started machining my first part on a lathe. And since then, I've had the wonderful opportunity of working with many different great CAD and CAM systems, including the product that we are going to be showing you today. So glad to be here.
Great, thank you so much. Well, we're excited to hear what you have to share with us today. Why don't you go ahead and share your agenda and take it away?
All right, will do. So anyway, thanks for joining us, everyone. Today we'll be looking at a unique product, and a product that can provide your CAM right within the existing Solid Edge software. The entire programming of the part, tools, G-code, everything all created and stored right in your own assembly and part files. Now, I am going to apologize up front if our presentation might seem a little more like a hard sales pitch sometimes. Hopefully it doesn't. There's just so much benefit to what you're going to be seeing today that we want to pack in as much information so that you can see what this is. Thanks to its integration, CamWorks for Solid Edge will help you significantly reduce the time that is required to create CNC programs. The fully associative tool paths will automatically update to the design changes. The other thing that it does is it allows for automation, unparalleled automation to further reduce your programming time and improve the quality of your part programs through standardization. We're also going to talk about optimization, showing you ways to where you can increase your cycle time, decrease your cycle times and increase your machine capacity. And finally, we're going to talk about verification. Using CamWorks for Solid Edge and CamWorks Virtual Machine, you can prove out your CNC programs to reduce the setup time and avoid the costly collisions. In short, CamWorks for Solid Edge is an ideal way to digitally transform your company through automation using feature and knowledge-based machining without having to go out and spend a lot of money on newer, faster machines. This allows you to use your existing software and your existing people and existing machines to get more output. And this is for anyone. This is for people that don't have a CAM system currently, as well as for those that already have a CAM system. It's made to work alongside your existing CAM software, provide additional benefit without the need to produce or to learn a new CAD system. Now, to get started here, I'd like to begin with a quote. The well-known former Prime Minister of the United Kingdom said, "To improve is to change, and to be perfect is to change often." Well, I don't know about you, but I kind of shy away from change. I like things as they are. But frequently, even though we don't like the idea of making changes, if those changes improve our situation, we should be quick to invite them. Hopefully during this webinar, I can give you some thought as to what changes you can make and how it can improve your business, and by doing so, improve your life. When integrated CAD is built into the CAM system, it really makes a huge difference for how you work. Your CAD is your CAM is your CAD. There's no need to maintain any separate CAD data and CAM files, and there's no risk of machining an obsolete revision of the part. The tool paths are also fully associative. If the design model changes, The updates can reprogram the tool paths automatically, changing tools, feeds, speeds, step overs, lead ins, lead outs to match those design changes without having to go through and wonder where you need to make the changes. Also, because of this, and because it's already inside your Solid Edge program, engineers and designers who are skilled Solid Edge users can also take on some of the programming responsibilities in order to fill the skills gap that is so prevalent in manufacturing today. To do this, CamWorks for Solid Edge uses feature-based programming. Now, if any of you have been watching these customer enablement series for a few years now, hopefully you've had this hammered into your head. Feature-based programming is good. Now, these machinable features that are fully associative to the model design can give you an 80 to 90% reduction in programming time as opposed to a traditional standalone operations-based CAM system. Let me show you what that looks like. We do this with built-in automated feature recognition. Now, this proprietary recognition technology, it discovers over 20 different types of machinable features. These can be recognized, added to the feature tray automatically. And on top of that, it then uses knowledge-based machining. Knowledge-based machining is a process by which we can capture your best standards and practices so that you can take all of the best skills and all of the best experience from your best people. And teach the CAM system exactly how to machine so that when it recognizes those features, it knows exactly what tools, feeds, speeds, machining strategies, everything it takes to make your machine shop run at its finest and to make your tools run their best. Now, given the shortage of skilled labor, these automation tools are more important than ever because they can help your company empower your existing labor force to do much more in far less time. CNC programs that used to take hours can literally be generated in minutes and even seconds through this automation. And the programs generated are much more consistent. You can promote standardization, which is wonderful in machining. Surprises are great for birthday parties, but they have no place in the machine shop. And on top of that, it then gives you time to optimize your programs so that you can reduce costs and improve quality down the road. To take a look at this in real life, I'm going to turn it over here to Marc, and Marc can show us exactly what it looks like in the program itself.
Thank you, Ben. Hopefully you can see my screen now.
Yep.
All right. And let's begin with the integration that Ben mentioned. Once CamWorks for Solid Edge is installed, it becomes part of your Solid Edge environment, and all the great features of CamWorks are available to you at your fingertips. A CamWorks tab is added up here to the Solid Edge ribbon bar. And over here on the left, 3 tabs are added to the command bar in Solid Edge, one for the tools, one for operations, and one for the features in CamWorks. And so we're going to suppose that this is a part that we'd like to machine out of a block of 6061 aluminum. And to start programming the part, what I'll do is go up here and press this button to extract the machinable features, or run automatic feature recognition, as we call it. And you can see instantly all the machinable features on this part are discovered, and multiple setups are created, and the features on each face are placed under the appropriate setup. The setups here, the 7 different setups or faces of the part that you see over here on the left, they can be used to create separate programs for each setup on a 3-axis machine, or as index angles for 3+2 machining on a 4- and 5-axis machine. And in addition, features of the same type and size are also automatically grouped and placed in groups for easy processing. So for example, all the counterbore holes here are all the same size and they are placed in a single group. And you see other hole groups here as well. And so that makes for easy processing. So once all the features have been discovered, we can go ahead and generate the operations. And this is using the patented technology database. And it will generate all the operations for machining the features. And you can see all the operations here have been created. And they're over here on the left now. And now that the operations have been created, I can go ahead and generate the toolpaths. And very quickly, you can see I've generated all the toolpaths now for machining as well. And we can go ahead and simulate the machining of the parts. So let me go ahead and hit the start button there, and you can see the machining of the part occurring right here in the Solid Edge environment. So all this is done right here in Solid Edge, and you can see how integrated and embedded CamWorks for Solid Edge is, and also you can get an idea of the automation and how much that automation adds to allowing me to be able to create a program, a CNC program, very quickly inside Solid Edge. So in just a few minutes, I've created this program. And now that I have the program set up the way I want and the simulation looks good to me, I can go ahead and generate the G code for machining. And I could save the file, give the file a name, and then I can single step through the G code or just go ahead and play it. And it will generate the G code for the machining of the part on the CNC machine of your choice. And we have a great library of proven post-processors that are available for a variety of different machines, everything from mill turn to 3, 4, and 5 axis mills, even EDM machines as well that we support through CamWorks for Solid Edge. And if I say OK here, we'll see the G code then open up in the CamWorks NC editor powered by Simco. So you can see the G code here ready to go to the machine. So that quickly I'm able to machine parts and program parts. And keep in mind that if there are particular processes that I want to change over here, and we'll look at that here shortly when we go to optimize a part of this program, we can make changes to it and then save it back to the technology database, and it will reproduce that automation just exactly the way that we decide we want it. So you can capture your best practices into the technology database. Okay. So now let's also see what happens if we make a change. So let's suppose that I grab this face and I drag it towards me a little bit and maybe change this just a little bit. Let me put an exact value in there. I'll put in 0.5 or ½ inch, for example. And we've made this change. So now the shape of that pocket has changed. Let's say there's an engineering change and that pocket needed to be changed. So I've made that change and I go back to CamWorks here and it knows that a change has been made. And now what I can do is go over to the feature tree and rebuild all of the operations and toolpaths for the machining based on the new revision of the part. So let me go ahead now and go to simulation and simulate. And you can see now the pocket shape in the top there has been changed. So that quickly the toolpaths have been updated and the change has been made. And I can compare the machine model to the design model using this button right here. And you can see green is good. Everything in green here is net to the design model. If there was any gouging that occurred, it would be in red. And if there was any stock remaining, it would be in blue. So you can see where the part has been fully machined exactly like the design model. And this comparison, show difference button, we call it, is a great feature that's inside the simulation. Okay. All right. So I guess that I'll turn it back over to Ben now, and we'll go from there.
That was fantastic, Mark. Thanks for giving us a demonstration on those things that I talked about. That integration and automation is fantastic, but it's not the only thing that we're here to look at today. So one of the things that this gets us to do is, I told you that with this integration, and it allows us to go back and maybe optimize our parts further, because we now have the time and the luxury to do so. And we have two technologies that I'd like to show you. First of all, as we've discussed, that was the wrong one. Anyway, so as we take a look at this, there is a technology called volume mill that we have out there. It's an ultra high speed rough milling technology that helps us reduce cycle times. As you can see there, 80% or more reduction in cycle time, increasing tool life by as much as 500%, and that's no joke. As a result, using volume mill, your company could possibly increase production by as much as 400%. And this is by not even changing machines or machinists. It's just programming differently, using your existing tools and machines differently. But we don't just leave it at the milling. We also have the ability to use the new Sandvik prime turning technology. The prime turning is basically a similar technology, but for lathes. It's been added to CamWorks to allow for a 2 to 3 times increase in feeds and speeds for turning, while at the same time, again, increasing your insert life significantly. That's one of the CamWorks for Solid Edge is actually one of the very few integrated cam systems on the market to offer this state-of-the-art technology built in. Now, the volume mill and prime turning, depending upon the level of CamWorks that you get into, some of the technology is built in, some of it is an add-on. But depending on your needs, you can get the exact specific pieces of this technology that you need and for your machines. I'm going to turn it back over to Mark so he can show you what this really looks like.
Thanks, Ben. Okay, so we were looking at this part, and we know we've made a change to that pocket on the top now. And Ben mentioned about the volume mill, and we'll look at volume mill first here. So let's go back over here, and I'll go to this roughing operation for that large pocket there, and I'm going to edit that operation. It's in my operations tree, and this dialog box will open, and this has all of the information required for roughing that pocket. If I go to the tool tab, it shows me the tool, what tool I'm using, tool holder, tool crib, if I want to use a different tool to machine that pocket. So, and there's also the feeds and speeds are here, as well as the other roughing parameters. So what we'd like to do first, let's take a look at the Optimize tab. And over here on the Optimize tab, we can see the amount of time that it's taking to rough out that pocket. And this is using a traditional, machining method here. And you can see it's taking about a little over 17 minutes, 17 and a half minutes to machine that pocket, or to rough out that pocket. And you can see it has to do it at a couple different levels because of the traditional type machining that's being used. And so what we want to do is optimize the roughing of this pocket. So let me go over here to the roughing tab. And if I go to the pattern here, you can see where volume mill is available to me and built in right inside the CamWorks for Solid Edge environment. So I'm going to select volume mill here, and then I can go over to the feeds and speeds tab. And what I want to do here is use the volume mill technology expert in order to adjust the feeds and speeds for volume mill, because it's much faster than traditional machining. It's typically 3 to 4 times faster in terms of the feeds and speeds. So I'm going to go over here and adjust this, and you see a little slider here. I can decide how conservative or aggressive I want to be. I'm going to put it over here somewhere in the middle, but a little bit towards the aggressive side. And then we'll also, we want to go to the roughing tab. We want to check that first cut amount, because now using VoluMill, we can use the full flute length of the cutter, not just a partial flute length. So I'm going to go ahead and make sure that that's set. That looks good to me. And I can go ahead now and preview it. And you can see how much different that toolpath looks, that VoluMill toolpath looks now on the screen as compared to the traditional toolpath. And if I go to back to the Optimize tab and look at the time, you can see this, the roughing of this pocket is now down under 1 minute. Okay, so we went from 17.5 minutes down to under a minute in terms of the time that it would be required to machine this pocket. And it's pretty amazing what VoluMill can do for you and the time that can be saved using the VoluMill. So you get a sense of how you can really optimize a program using VoluMill. And again, this could be saved back to the technology database so that VoluMill is used all the time for all my roughing. And that's also an option, right? So, and that's typical. Once you have VoluMill available, you probably don't want to do rough milling any other way. So you can make a part of your technology database, and it'll be generated, all the rough milling will be generated for you automatically using the technology database and using VoluMill. Okay. All right, so now I want to show you another example, and that is a turning example. So let's look at this part, for example. And here is a simple turned part. And what we can do, again, is program this very quickly using CamWorks for Solid Edge. I'll just go ahead and extract the machinable features on the part, and you can see it very quickly finds the machinable features. I'm going to suppose I'm going to machine this out of a slug rather than, so I won't need a cutoff here. So let me just take that cutoff and delete it. And you notice when I delete it, it will go over to the recycle bin, so I can always restore it if I want to. Now that I have the features, I can generate the operation plan, generate the tool paths just like we did before, and now I can simulate the machining of the part. So let's go ahead and simulate the machine. I'll slow this down just a little bit, and then we can watch the machining of the part. Okay. And this is using traditional tools, CNMG 432 inserts for the roughing, and I believe it's a DNMG insert for the finishing. So you can see this is using typical traditional tool paths here. And if I go ahead and right click up here on the turn setup and edit that setup, I can go to the statistics tab and I can see it's taken about 6.6 minutes to machine this part using the traditional tools and feeds and speeds. So now what I'd like to do is optimize this turning operation using prime turning. And so I'm going to go over here to the feature tree, and I'm going to change the strategy that's being used for the machining of this OD feature, the outside of the part. And I can change that using the parameters. And here you can get an idea of how I can store various strategies for machining different types of parts. Maybe I want a real good surface finish, or there's a very close tolerance. I can have a separate strategy for that type of part, and I can store that and reuse it easily and automatically. So here I'm going to select the prime turning strategy and use it. And now that I've selected that, I can go ahead and generate the operations again and generate the tool paths again. And you can see where now there's some prime turning inserts and tooling that are being used for the machining. That's thanks to my prime turning strategy that I have stored in my technology database. So I'll go ahead now and simulate the machining. And you can see now it's using the prime turning method, which is to machine from the back to the front. Okay, very much different from traditional machining, but also much faster. And in addition to a 2 to 3 times increase in feeds and speeds, you'll also see insert life for these prime tools is increased by typically 500%. So you typically get 5 times greater tool life out of the prime inserts versus traditional turning and inserts. Okay. Also, if I go and look at this setup again and take a look at the time that's required, you can see where it's down to 3 minutes now. So I have now doubled the capacity of my machine simply by changing the method that I'm programming with, and I can get twice as many parts. That's less than half the time that we saw earlier using traditional turning methods. So you can see how valuable that prime turning can be, and how much time it can save. And of course, time is money. So it really makes a huge difference, and it means you can produce far more parts and do it more quickly, make deliveries more quickly, and so on. So, all right. So let me turn it back over to Ben now, and we'll go forward.
Thank you, Mark. As you can see, no lie, there's some significant advantages to this technology. Hopefully you're realizing that this is all inside Solid Edge. So it's an amazing product. It's meant to not disrupt your existing workflow in any way. It's meant to just simply enhance what you already have. So let's take a look at the next one. Now, we're running out of time, but I really want to show you this, and that is virtual verification. We've examined the technology for integration, automation, optimization. Verification can be absolutely invaluable. CamWorks Virtual Machine is an add-on, and it leverages true G-code machine simulation to help you virtually prove out your CNC programs and help you cut setup time by 50% or more. And in fact, in many of the products that we have, this virtual machine verification without the G-code is baked in. So you can still do machine simulation using your apt or cutter language code. But this G-code is absolutely amazing. Imagine being able to take and detect for collisions of your machine components, your work holding devices, tools, and do it without running into those problems on the machine. Machine crashes are extremely costly. Not only do you have to deal with the hardware itself, but also the downtime, which can even be more expensive in most cases. So let's take a look really quick to see how we can avoid these broken tools, avoid this downtime, avoid these expensive repairs using CamWorks Virtual Machine. Mark?
So let me show you this part here is in Solid Edge and is in assembly, in a Solid Edge assembly. And you can also program parts in Solid Edge assemblies. And here you can see I have a vise and a table and stock and all that, so that I can simulate the machining of the part here in Solid Edge assembly mode as well. And I'll just go ahead and hit simulation here, and we can quickly watch a simulation of the part being machined. And I'll speed this up a little. And you can see the simulation includes the holder and tool and vise and so on. And all these are collision checked against right inside Solid Edge. But there are parts and portions of the machine I can't see here. And we don't get full machine simulation unless we add the virtual machine. So CamWorks Virtual Machine is integrated right in. If I just right click on the machine here and I ask for machine simulation, and I have the option to use the G code here for the simulation, for the full machine simulation. And of course, if I'm going to use the G code, I need to post-process it first. So I'll just quickly post-process the program and then go ahead and open the CamWorks Virtual Machine so that I can see what the entire machine is going to look like and get a very good idea of how this part is going to be machined right on the machine. And you can see it here where everything has been transferred for me, including the vise and stock and the and the G-code and all that, and if I go ahead and start the simulation, we can see right away that a collision occurs actually because of this nozzle that's on the machine. We could have never seen this in a standalone CAM system without full machine simulation, right? So here's machine simulation showing us that there's going to be a collision that occurs. So I can let the operator know that they need to get this nozzle out of the way and either move it back or remove it. And what I can do now is go ahead and say I've done that. So I'm going to disable collision detection on that particular part, and then we'll go ahead and continue machining. And now we can see the machining of the part. And this is from the actual G-code over on the left is being processed. And so we get true machine simulation from the actual G-code, and we can see if a collision is going to occur. And really a great time saver and money saver in terms of collisions. It can be very expensive, as Ben said, when a collision occurs on the machine, broken tools, sometimes damages the machine and downtime and so on. So you can get an idea here of how valuable CAMWorks Virtual Machine can be. So, okay. All right, back to you, Ben.
Great, thanks, Mark. All right, so let's take a look at this. It gets down to the nitty gritty. What does this work for? What doesn't it? We have seen some amazing technology. Hopefully, it's something that you could take a look at and say, is this something that I need to change that will benefit me? But what does it actually work for? Who is this for? CAMWorks for Solid Edge, we produce this for people in all sorts of different situations with all sorts of different types of machines, anywhere from 2-axis knee mills to big multi-turret, multi-axis mills and lathes that do just amazing single setup things, and even wire EDM as well. So really, it's a customized fit to see which exactly which one of these particular professional standard or premium licenses fits what you want to do. Here's the big key. The key is that this is made, it's very, very easily powerful and can replace any CAM system out there in most cases, but that doesn't mean that it fits with your particular workflow. And so we have made this to be a product that does not disrupt an existing workflow. Maybe you're an existing Solid Edge customer and you want to implement CAM. Why would you want to use this one? Well, using the things that you've seen so far, you'll want to use this if you're looking for something that's integrated, that you don't have to keep track of 2 different files, a CAD and a CAM file separately. And so maybe that's the thing that really makes your workflow better than that of, say, something like Solid Edge CAM Pro. But take a look at them, see what works for you. Also, the benefits that you can see, maybe you already have an existing CAM system. Maybe it's Solid Edge CAM Pro, maybe it's an outside system outside of Siemens, and it's already built in and it's working, you have legacy data. This product is built because it works and it's integrated right within your Solid Edge. It can be used and not disrupt your existing workflow. It can actually run simultaneously. You can say, okay, I'm going to take these specific parts that we do, and we can use the CAMWorks for Solid Edge right within the Solid Edge file, and these other parts that we do, we just do our traditional workflow. And so the net benefit is always positive. It's not a negative at all. You're always getting the benefit where it fits your production and your workflow the best. It's very, very affordable to get into, and it also has some, as you can see, some great technology in it. So what are the takeaways of this? Well, first of all, leveraging that integration and automation to accelerate your program is a huge benefit. And you can do that with your existing employees and existing machines, and you can even reskill the employees that you have to learn this type of automation. Also, you can do the optimization that maybe you've always wanted to do. You can get these parts dialed in and working so that you're improving your tool life. You're costing less to produce each of your parts. And then finally, as you do this, using verification to reduce setup time, avoid collisions, reduce your downtime, and make sure that things are actually happening the way you want them to happen before you run into a physical issue on the machine that could so severely impact your production. And that's it. Digitally transforming your workflow using today's technology is something that is very, very good to look at. And we're here to provide you these tools to help and see where it fits in yours so that you can accelerate your time to market and you can have better on-time deliveries going forward, including the machines that you already have and the workforce that's already working for you. Well, with that, that's the end of our presentation, but we don't want to go before answering any questions that you may have.
Great. Thanks, Marc and Ben. It does look like we have a few questions. The first is, can I machine parts from other CAD systems using Solid Edge?
Oh, definitely you can. In fact, anything that you can bring into Solid Edge, anything that Solid Edge will open, whether it was created in Solid Edge or not, you can program with CamWorks. Any thoughts on that, Marc?
Yeah, no, I think you pretty much summed it up, Ben. Virtually any solid model that you can bring in through or into Solid Edge will be machined, and CamWorks for Solid Edge will work exactly the same way on an imported model as it will on a native Solid Edge file.
Great. I think you touched on this question, but I'll ask it. It's, should I look at CamWorks if I have an existing CAM system like CamPro?
Great question. Yes. It's very good to look at CamWorks, even if you have an existing CAM system, even if it's CamPro. There are some advantages that hopefully you've seen to use some of this technology. And because of the fact that it's running right within your CAD file, in the Solid Edge file, it doesn't disrupt your workflow. You don't have to learn a new interface. It's not going to be difficult to implement. It's literally just learning some more functionality in that file. So then you can pick and choose the best workflow with the CamWorks and the best workflow with your existing CAM system to optimize what you're doing every day without having to disrupt the entire flow or buy new machines or severely retrain employees.
Nice. Another question we got is, can the technology database be used to create a list of standard tools for each of my machines?
Yeah, I'll take that one, Ben. Sure. I mean, that's you can create various machines inside the technology database. Those then appear in a list for you to be able to select within your CamWorks for Solid Edge user interface and easily pick them from a pull-down list. And then you can also have a set of tools for each of those machines that is maybe a standard set of tools that you typically use on those machines. You can bring those up and have them loaded or installed right along with that machine. So, and the post-processor also gets selected when that occurs. So you pick that machine. So.
Nice, thanks. And our last question is, can I store feeds and speeds for tools in different materials?
Yes. So feeds and speeds for different tools and different materials can be stored either in the technology database or even in the user interface. There's the ability to be able to save proven feeds and speeds to the database and to the user interface, so that whenever you pick a tool and you're in that material, it will automatically select the correct feeds and speeds for using it, and even depth of cuts as well.
Nice. Well, I think that's all the questions we have for today. If you're ready to take it to the next level, Saratech offers much more than software. We have a wide variety of options for training, services, and 3D printers. So if you have any questions about that, you can always email us at marketing@saratech.com. Thank you so much for attending. Thank you, Marc, and thank you, Ben, again for being our guest presenters. And I hope everyone has a great day.
Thanks for checking out our channel. If you like what you saw, make sure to like and subscribe down below so you don't miss out on any new videos. Follow us on LinkedIn, Facebook, and Twitter for the latest engineering news and information. And to see all of our upcoming events, please visit our website at saratech.com/events.